Hi guys, this video is about teaching you guys how to determine the tidal window in the topic of tides. So tidal window refers to determining the safe time for a vessel's passage with the required underkeel clearance as well as the required height of tide. Now my first video was on tides, discussed the theory on tides. It was just a theoretical discussion. The next video was a discussion on, rather not a discussion, but it showed you how to calculate the height and times of tides for secondary boats with the standard port as a reference. And this video will focus on determining the tidal window for safe passage of a vessel. Now let's take a question so that it's clearer to you on what I want to attain through this video. So the question here says that there is a vessel which is maybe in a port with a draft of 12 meters. Alright, so let's assume that the vessel has completed its cargo operations. It wants to depart from the port and it has a draft of 12 meters. That is the height of the water from the keel to the water level. So from the keel to the water level is the draft. So that is 12 meters. The vessel requires an underkeel clearance or UKC of at least 10% of the draft. So that means when the vessel departs, it wants a clearance from its keel, that is from the bottom of the ship to the seabed, by at least 10% of the draft. 10% of the draft is 10% of 12 meters in this case, which is 1.2 meters. If the dynamic squat leads to the sinking of the vessel by 1.3 meters, that means if the vessel, while it's transiting a channel, every vessel that transits a channel, if it has a low depth of water below it, then what happens is the water that is passing below the keel of the ship kind of tends to speed up. So higher the speed, higher is the movement of the water below the keel. Due to this movement of the water below the keel, or the speedy movement of the water below the keel, there is a Venturi effect or a suction effect. This suction effect leads to the vessel sinking further. It gets sucked towards the bottom of the seabed. So the sea bottom rather. So that leads to further sinking. That is the reference to dynamic squat. So if the vessel is going to sink further by 1.3 meters and the channel depth is only 13.3 meters, find the height of tide required and the safest time of transit. Alright, so to do so, we will, or to find out the answer, we will be using this popularly known graph, which is used for finding the height of the tide at times between the high and the low water. Alright, so let's determine the tidal window here, but let's consider the information first given to us. The information given to us is that the draft of the vessel is 12 meters. The dynamic squat will lead to a further sinking by 1.3 meters. And at the same time, we need a 10% of the UKC or underkeel clearance below the keel of the ship. So altogether, we need a maximum depth of 12 plus 1.3 plus 1.2, which is 14.5 meters. But the channel depth is only 13.3 meters. That means we need a height of tide of 14.5 minus 13.3, 1.2 meters. So that's the height of tide required for us to safely transit with a UKC of 1.2 meters. And let's now determine what will be the safe time to do so. So to do so, we will go into and we'll assume some values here. These values, I am assuming this for this question, but basically you can find out the low water and high water height of times and height and times from the Admiralty tide tables for the port in question. So we have Admiralty tide tables available to us on the ship, and if we go into the Admiralty tide tables for any port in question, for the given date and month, you can find out the low water and the high water times as well as height. Here I have assumed the times and height here. So let's assume that we had two low waters and one high water on this day. The low water one time is 0803 with a height of tide of 0.5 meters, and the high water is at 1407 and 1.6 meters, and the low water 2 is 2013 at 0.3 meters. Now normally if there are two low waters, there is also two high waters, but in this case let's assume the next high water would have occurred on the next day. That is why only two low waters and the high water is given for the date in question. Now the first thing that we will be doing for using the graph here is that we'll be connecting the low water 1 height to the high water height. That is, we'll be connecting 0.5 meters to 1.6 meters. How do we do that? Well, if you see the graph here, the bottom horizontal line is the low water height and the top horizontal line is the high water height. If we take the required scale of 0, 1, 2, 3, 4, that is the first scale available to us, join the 0.5 meters of low water from the bottom to 1.6 meters of high water at the top. That is the blue line. Alright, and now we know that our height of tide required is 1.2 meters. So using the same scale at 1.2 meters, we draw a perpendicular line. That is the black line here. So at 1.2 meters of the required height of tide, we will draw a perpendicular line. Alright, now wherever it intersects the blue line, we will be drawing horizontal lines to the curves here. Alright, but where do we stop? So to stop, we have to see that you see the curves here. Now the center of the curve that you can see, you have high water written there at the bottom. Alright, where you see 1407. So that high water refers to the high water time. So if I put the high water time there at 1407 based on this example here, we will see what is the time that the first low water is occurring. It is occurring at 0803. That means it's occurring about 6 hours before the high water. So if you see the curves, you can see the curves are for 7 hours before high water, 6 hours before high water, 5 hours before high water on either side. That is 7 hours before and 7 hours after. So on your left hand side, the curve starts with the 7 hours before high water, 6 hours before high water and 5 hours. And on the right side, you see it's ending at 7 hours after high water, 6 hours after high water, 5 hours after high water. So because the first low water is occurring at 0803, which is 6 hours before the high water of 1407, we will draw the black horizontal line up to the point of the second curve, which is at 6 hours before high water, and we stop there, and from there we draw a vertical. That vertical line gives us the time of the safe transit before high water. That means it will be somewhere around 2 hours and 10 minutes before the high water. We do the same thing for the next one. So we join the low water 2 to high water, that is 0.3 to 1.6 meters, and that is the red line here. And again, because our height of tide required is 1.2 meters, wherever the black line intersects the red line, from there we draw a horizontal line, and this time we go up to the low water 2 time. The low water 2 is occurring at 2013. That is, it's almost occurring at 6 hours after high water. So we go up to the graph or to the curve which is drawn for 6 hours after high water, and we stop there. Alright, so we stop there and we draw a perpendicular line again. So that gives us another time. So that means the vessel will be safe to transit 2 hours before high water and 2 hours after high water, when it will have a height of tide of about 1.2 meters, which will also give us the required underkeel clearance. So if the vessel travels anywhere between 1207 to about 1607, that is 2 hours before high water and 2 hours after high water, it will have the required height of tide for transit of vessel. So that is the tidal window. So if the vessel needs to depart, the master needs to inform the port authorities that it will do so only within this tidal window. Alright, so I hope this was easy enough for you to understand. If there are any questions, any doubts, please write in the comment section and I'll be happy to address them. I want to keep these videos short to hold your interest, but if there's something you didn't understand, please let me know. Thank you for watching, guys, and thank you for subscribing. Keep subscribing so that you get notification about my further videos. I'll be preparing some videos very soon on orals preparation for Chief Medicine Masters, so stay tuned. I'll see you guys soon with the next video. Bye guys.